All right, welcome back. So now here we are. We're in chapter 3 in the text. And we're going to talk about data mining or mining insights. Coming up with insights from the data that we have. That's the best way to word it. So machine learning will allow us to programmatically find out insights from the data that we may not even realize exist. Extracting features that are important that I didn't even think that feature was a big deal. But we've got models that exist that when we apply these models to a specific data set, we can identify what features are significant. And from there, that'll help us make great decisions moving forward. So we're going to dig into machine learning. As I mentioned in the overview video, there'll be another video walking you through Orange and the concepts associated with what we're going to do in there. That'll be in the resources tab as well as in the assignment itself. So with that said, I've mentioned it previously that we've kind of flipped things around. We've turned the tables on how we look at things in programming when it comes to data. Previously, we thought we knew everything and we said, here's the rules, let's go do this. Now, we've written algorithms that say, I don't know the rules, you tell me what the rules are. And the algorithm will then go through, analyze all the data, and tell you what rules exist, what's important. Maybe there's causation. We see it all the time. We see it, and they mention here in the book, Netflix. Your Netflix suggestions, should you have Netflix, that's machine learning going through and analyzing data associated with you to identify significant features or trends in your viewing preferences or what you like to watch or your viewing history. It's all right, based on this and the data collected associated with other people, we can say this is what you would like to watch next. Well, really throws a wrench in things when somebody else used your Netflix and watched something different. And I talked about it before. Our data can be compromised very easily. And that's what takes place when they're assuming all the movies watched are being watched by me because I put my name on that user. They want to be able to give suggestions for that individual user, not the household. But when somebody else comes and watches it using my profile, or my user account, whatever you want to say, then those viewing pieces of data get tied to me, which throws off the projection. So when it comes to data, we need to know how reliable it is, how accurate it is, how it was collected. We've talked about some of these things in the previous module and dealt with in the last couple of LinkedIn Learning tasks that you had quizzes on. So we're understanding that we're exploring the data. We're trying to find out what's important. Well, the tools we use to find out what's important, we call machine learning. The machine learns based on what it sees and finds in the data what's important. Okay? We've talked about different algorithms associated with it, like k-nearest neighbor. We apply statistics to, based on statistics, identify, and the example I used in previous lecture was in skin cancer diagnosis, remove the hairs, we inpaint values into those pixels that were identified as being associated with hairs. We inpaint based on K nearest neighbor algorithm. That's a machine learning algorithm. The system learns that let's go look around statistically at the other pixels and see what's there, and then we'll apply statistics to inpaint a value there. So we're using statistics along with machine learning to predict what's taking place. Now we've got a variety of different descriptive statistics and methods that we go through to predict some outcome or come up with an inference. Now, we say that we're going and looking at different features. Let's say that I look at different features of a person. And it could be your height, your age, your weight, where you grew up, what you do for a living, a variety of different features. And I capture that data. I've got data associated with, say, 100,000 subjects. So, the population, I've got 100,000 samples that I'm going to deal with. And based on those 100,000 samples, I want to be able to predict how long you will live. Now I've got to go through and look at historic data on those samples, how long they lived, and look at what features directly tie to longevity. And I'll come up with a correlation between the features. We come up with what was called a correlation matrix. And we identify the different features that are important based on the correlation matrix. And I may not at a glance know what's important, but statistically the machine or my computer algorithm can go through and learn what's taken place, what's important, and go from there. Okay. So we've got a variety of different applications of machine learning that we deal with on a day-to-day basis. Predictive maintenance, product recommendations, spam filter. Based on specific criteria, it looks at, so we've got a model that exists, it's been tested, it works. It's successfully identifying spam. So now we've got that model, we just run everything through that model to classify it as spam or not. That's what takes place. Social media, we can do sentiment analysis. I can take keywords in text that people have posted in social media, and based on those keywords I can classify different words as being positive or negative. Then from there I can say, all right, this person's posting a lot of negative things, this person's posting a lot of positive things. Well, the same word can mean something positive or negative in a given context. So this is not as good as we would want it to be. Right? Chatbot for customer service. These things drive me nuts. I can't stand them. When you get the spam phone calls, that's a chatbot. they have pre-recorded responses, or based on your response, they will react accordingly. All right, it's all cause and effect. You cause them to go do something based on whatever words you provided. All right. So we've got a process that we go through. And when we're talking about machine learning, we start out with our data. Now, we're going to make sure that our data is clean. We're not missing things. Everything's uniform from one record to the next. It's formatted the same way. I want to make sure that values are ordinal. I've gone through and I've done one-hot encoding on things like male and female. I made them a 0 or a 1. I've done a lot of cleaning to make sure that the data is the way that it's supposed to be. And I have what I need to do what I've got to do. So once my data is what I need it to be, and I feel I can trust it, I then choose a model. Now, I don't have to go create a new one. Like I said, this is programming. We're not actually going to be doing the programming, but we can use models that have already been created by programmers. So I find an algorithm that somebody else has already created, and we say, well, will this work on what we want to do? It may. Let's go see. Now, I've got my data, and I need to choose a model, but the data, let's say I've got 100,000 records. And those 100,000 records are classified as positive or negative. I know they're all positive or negative, and I want to create a model that will determine, based on specific features, if it would be positive or negative. Think back to cancer diagnosis. That's what I'm doing. I'm taking images and, based on features in the image, diagnosing it as melanoma or not. So with that said, I need to break my data up into two groups. I need a training set and I need a test set. Now, depending on who you deal with, when we're talking about data science or AI education, they may call it train and test. They may use other terms. All right. We're going to use train and test. I train the data with one set, and I train the model with one set, and I test the model with another. So of this huge data set that I got, I'm going to say 70% of it will be used to train the model. And that 70% we feed into the model and say, hey, go find out what you need to find out about these records to be able to accurately classify records that aren't classified. So here's 70% of this massive data set that I have. Go learn from it. And that's what we're doing when we train the model. And what the model does is it goes through and it goes through different epochs. And it says, all right, let's go try this. Okay, that didn't work. Let's try this. I did a little bit better. Let's change things around and try this. I'll try that. This algorithm goes through and explores all these different options to learn what works and what doesn't work when trying to predict a class, or to classify an unknown. And it goes through over and over again using different features and different combinations until it comes up with one that it thinks, man, I've got a 98% accuracy. I'm doing really good. I'm good 100% of the time. I'm always guessing it. Man, if it comes back and it's training and it's at 100%, and it's got to work when I go test it. Now we get down to step 4, and we have to test it. So we take that remaining 30%, and we feed it into this model that's been trained, and say, all right, you're 100%? Show me. Here's 30,000 records out of the original 100,000. Here's 30,000 records. Go classify each one of them. Now, I know which class that they are. I have the true value of what class they are. But the way that we run the test is it goes and looks at the features, but it doesn't look at what the actual classification is. It tries to predict it. And then ultimately what we're going to do is we're going to say, all right, that 30% that we ran our test set, of those 30,000 records, how many did you predict right? What percentage were you right? When you went and trained, you said you were great all the time. You were 100%, you were spot on. But now we got to evaluate the model with the test set. How accurate are you? Not as good as I thought. All right. Let's go back and we'll change some attribute of the algorithm. And this is something we'll do in future classes, but we may want to, when I mentioned epochs, we may want to run through bigger epochs. We may want to run 80-20 split on training and test. I may want to go and try and train it again. Maybe there was a bad sample in there that threw off. Maybe something threw off my training. Okay. So we'll go through until we come up with, and that's our fine tuning, we'll go through and fine tune different parameters in the algorithm to where maybe this will give us better results. We want to avoid overfitting. And that's almost like it's trying too hard. It's like the algorithm's arrogance. Yeah, I got this. I'm always right. And it's not. So these hyperparameters that we're going to check on, it could be the learning rate. It could be the number of epochs. There's a variety of different things that we could go through and change. As I said, that's for another course. But that's what we're going through when we're training our model. So we picked a model, we've trained it. I said, there's different algorithms I could try. Maybe this algorithm worked for what I want to do and that one didn't. If I set my code up properly, and I could do this, like I said in previous lectures, I'll do it in Google Colab. I'll just copy my notebook, create a duplicate, and just change the algorithm. Let me try a different algorithm. Maybe another algorithm works better on what I'm trying to do to predict the outcome. It's a lot of testing. That's what this data science is. Just going through and testing. Let's see what works, what doesn't work. Don't assume just because you got good results that that's the one you got to go with. We have to keep testing to make sure maybe it got lucky. And then when I go test it with something else, that won't work for this. So we've talked about it before, you've dealt with it before in previous modules. Supervised and unsupervised learning. This is unsupervised learning. We're dealing with data that has no classification labels. And we're going to feed it in, and you tell me, what is this, or what is it not? And that's where this becomes quite a challenge for different algorithms, because now we may not know what the rules are to be able to classify. We're coming up with classifiers. That's what the examples that we're going through now are. Okay. No. Reinforcement learning is that we'll do the same thing over again and do this trial and error process, and you get better over time by trying things over and over again. Now, just because you did something twice doesn't mean that you actually learned from it. It may have worked the first time, and it may not work the second time. Okay. But reinforcement learning is a key area within machine learning. We've got supervised and unsupervised, and we've also got this hybrid somewhere in between the two, which is semi-supervised. Some of the things I'm going to tell you, I'm going to tell you what some of the rules are. The rest of it, you're going to go figure out on your own. And when I say you, I'm talking about the algorithm itself. So, we're talking about machine learning. We've got supervised and unsupervised. And when it comes to supervised, we've got common ones are classification and regression. Classification, well, I want to classify it as cancerous, not cancerous. Student, non-student, whatever it may be, what are we trying to classify? Okay. We've got regression analysis, a variety of different forms of that. And then we've got unsupervised learning, where we've got clustering, where it tries to group things together based on some feature. Let's go and group these things together, and it's k-means clustering is we'll group them together based on how close they are to a k-nearest neighbor, if you will. So I would assume an instance of this would be, and it'll give you an idea how flawed it can be. But if we looked at the individuals that lived within 5 houses of each other, we would classify by a political party based on the 5 nearest neighbors and their political affiliation. So if we look at the 5 nearest neighbors, and statistically they're predominantly one political party, then we can assume that an unsupervised learning, that would make you a member of that political party. Not so much. So when it comes to the rules, supervised, unsupervised, supervised, we can end up with better results. Unsupervised, it takes a lot more learning for things to be very accurate. We've got different classifiers that we have available to us. Naive Bayes, K-nearest neighbor. We've got linear regression. They talk about different examples of each one. And it's all things that we've talked about already. And the fact that it's statistics. So, go back through, read through this. Interact in the discussion. Make sure you do the reflection. And check the resources as well as the videos in the programming in orange assignment. Okay. So see you in the next video.